5c, the first question, just using the arc length equals r times theta formula. Nice small formula to use here. And so for part A, well, we've got r and theta. We're just going to times the two of them together. 6 times 0.45 is 2.7, and that would be centimetres. For actually it's then part 2, isn't it? Again, just doing r times theta. So I've got 4.5 times 0.45 to get 2.025, just timesing them together. And for part 3, for that one, just timesing r and theta together, I've got 20 times by 3/8 pi, which I'm going to leave as 7.5, or 15 over 2 pi. So for the first one, you're just using the formula like that. For part B, though, you've been given 10 for the arc length, and you've been given that the angle here is 0.6. So we're just going to divide. 10 divided by 0.6 is 50 over 3. And we're doing the same for part 2 there, that we've got a length of 1.26 equals r times 0.7. And so this time r is 1.8, doing 1.27 divided by 0.7. And the third one of those, I've got an arc length of 1.5 pi and an angle of 5/12 pi. And so there, I'll just divide this by this. The pi's will cancel out, and I'm left with 3.6 for the radius there. Last section, again, it's the shortest formula you've got to remember in maths, but this time you've been given that the length is 10 and the radius is 7.5, and you need to know what theta is. So 10 divided by 7.5 is 4/3. For part 2, we've got 4.5 here and 5.625 there. So 4.5 divided by 4.625 gives me theta now is 0.8. And for the last one, we've got root 12 here and root 3 as r. Divide both sides by that. So I've got root 12 divided by root 3, which of course is root 4, which is 2. So pretty quick, just throwing those numbers into the formula for the first question.